Hey guys, Mr. King here. Today we're going to switch gears a little bit and we're going to start talking about energy. And you guys know you have lots of energy, but there's a little more detail in energy than just running around a room or feeling really hyper and things like that. There's different kinds of energy, and all types of energy kind of have one thing in common. All types of energy have the ability to cause change. So we're going to talk about two main types of energy today. We're going to talk about potential energy and kinetic energy. And we're going to talk about how those different types of energy are used in the world and how you use them in different experiments to determine how fast things move and how much energy is behind them to cause change. Now you can imagine if you're running really fast and you slam into someone, you would cause a lot of change. The faster you're running, the more energy you would have. If you're going really slow and you just bump into someone like in the hallway, you would have a very little amount of energy and you wouldn't cause much change. You might just brush by them and they'd barely notice, as opposed to if someone's going crazy and running down the hallway and they run into you, you'd definitely notice. That would cause a change. So that's what we're going to focus on today, are those types of changes that are caused by energy. First, I got a little video for you about roller coasters. And roller coasters are great examples of energy because they change potential and kinetic energy back and forth. So check this out.
You may be surprised how much math and physics go into amusement park rides, and more specifically, roller coasters. Common roller coasters don't have an engine, so something has to keep it moving through its fun and intense track. The key to making a roller coaster move is energy. Well, the roller coaster uses a motor to get to the top of the hill. And in the process, it is storing energy for later use, which is called potential energy. Then, you finally get to the top of the hill and gravity pulls you down the track, which increases your acceleration and velocity. This turns the potential energy to kinetic energy. Kinetic is energy that is being used, or energy that is caused by motion. The roller coaster goes faster with more kinetic energy being used, which is why the car gets faster towards the bottom of the hill. The change between kinetic energy and potential energy changes throughout the ride. Eventually, the energy turns to friction from wind, the rolling of the wheels, and the brakes on the track. So you can blame friction for stopping the speed and enjoyment of your next roller coaster ride.
Alright guys, so that shows you a little bit about how roller coasters are used. And it talked about how energy transfers from kinetic energy to potential energy. And energy transformation is the same as other types of transformation we've talked about this year. Energy changes from one form to another without any being lost or gained. This is kind of like the law of conservation of mass or the law of conservation of matter. It's the same idea. When you change something from one form to another, nothing disappears and you can't gain something out of nowhere. It just changes form. And so when you're going on a roller coaster, your energy transformation happens from the amount of potential energy you have built up. That's how much kinetic energy or speed and movement you get. If you guys have ever been to Cedar Point, if you ride Top Thrill Dragster or Millennium Force, those go really high. And therefore, when they release, after you've gone up really high, especially on Millennium Force, on that first hill, if you go really, really high, you build potential, you build potential, you build potential, and then you drop, that all potential energy gets transferred into kinetic energy. So the more potential you have built up, the more kinetic it can transfer to. Going along with the transformation, it's not lost or gained. It has to be there originally. So if you go on a roller coaster that's got a small first hill, you're not going to go very fast because you build your energy up when you climb that first hill. Once you drop off that first hill, you just depend on the amount of potential energy you had stored up to take you through the rest of the ride. So the transformation is just like everything else we've talked about. Nothing disappears, nothing automatically is gained. It just changes from one form to another. So the type of energy that is when you're moving is called kinetic energy. Any object that is moving has kinetic energy, and an object's kinetic energy depends on two things: its speed and its mass. So if you have an object that has a ton of mass, like a semi-truck, and it's going very fast, like 70 miles per hour, that has a ton of kinetic energy. And if you remember at the beginning, we talked about energy is the ability to cause change. So a semi truck going 70 miles per hour down the road causes a lot of change. You guys have probably seen some deer that have been splattered on the road from a semi truck colliding into it. And that's a lot of change. Now that's going to have way more kinetic energy than like a person walking down the hallway. When you guys transfer class, you guys walk from one class to another. You have kinetic energy because you're moving. Now you don't have a ton of kinetic energy because your speed is pretty low and your mass is also pretty low. So you have to look at both of those factors. Now you can have a really small object that has a lot of kinetic energy. Imagine a baseball after it gets hit by someone. That baseball could be traveling 100 miles per hour. Even though it's a small ball with a very little amount of mass, that still has the ability to cause a ton of change. When objects collide, kinetic energy can be transferred. Let's say you're walking down the hallway and there's some kid running down the hallway and he bumps into you. His energy, his kinetic energy, is going to be transferred into your body and you're going to start to move. Even if you were standing still, if he bumped into you, that might knock you into a locker or knock you into another person, and that would knock those people down as well. It's kind of like dominoes. If you guys have ever seen dominoes before where you stack them up, all you do is touch one and all the rest fall one after another because their energy gets transferred from one domino to another. Another great example of kinetic energy is when you're bowling. When you're bowling, you hit the pins and the energy from your ball that you threw down the lane, when you get a strike, you don't hit all 10 pins with the ball. You hit about 5 pins, and those 5 pins jump around and hit all the other pins. They transfer that kinetic energy from the ball to the pins. Kinetic energy, when you're moving, can also be converted to heat energy. They talked about on the video how you slow down because of friction. If you guys were to go outside right now and kick a soccer ball along your grass, it would slow down because the kinetic energy from the movement of the ball would rub against the grass, and that would cause friction to slow the ball down. Now, when two objects rub against each other, that creates heat. You can do that right now with your hands. Take your hands right now, put them together, and rub them together. And as you rub them together, you can feel how warm it gets. That is from your kinetic energy being converted to heat energy. The faster you rub, remember kinetic energy is speed and mass, so if you increase your speed, the more heat you're going to create. If you rub your hands together very slowly, you don't get much heat. But if you rub them together as fast and as hard as you can, you're going to get quite a bit of heat. Okay, so kinetic energy is anything that is moving has kinetic energy. Now, potential energy is the other type of energy. Potential energy is stored energy due to an object's position. And you can see in this diagram in part A, the roller coaster is up on the top of the tallest hill. And that would mean it has a lot of potential energy, but very little kinetic energy. Because at that point, if you guys have been on a roller coaster, you guys know how you go up, 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 up. And then there's that point where you go really slow right at the top before you go over that hill. That's point A. Okay, your potential energy is really high because you have all this stored up energy ready to be released. Your kinetic energy is pretty low because you're moving really slow. Now, as soon as you get over that first hill, you gain speed and you go really fast down that hill, and then you get to point B. Now, your potential energy is pretty low because you have not got a lot of stored up energy because you're pretty low to the ground. Your kinetic energy, on the other hand, is very high because you have tons of movement because you just came off this giant hill. So potential energy, it depends on how high up an object is. Potential energy can also depend on like chemical bonds. A tank of gasoline has a ton of potential energy because it's got stored energy. All you have to do to release that energy is light it on fire and you get a huge explosion. So when we transfer this energy, potential energy can be transformed to kinetic energy, and kinetic energy can be converted to potential energy. If we go back to the roller coaster, you have all that potential energy was built up at point A. That all got transferred to kinetic energy as it went down the hill. Now at point B, it's going to go back up the hill, and that kinetic energy that it has is going to become potential energy because it's going to store that energy as it goes up higher. Then after it goes over the second hill, that potential energy that it stored will become kinetic energy again. So not only can potential energy turn into kinetic, kinetic can also turn into potential energy. Here's another video kind of explaining the differences between the two. Check this one out. It's got a catchy little song.
The rolling boulder crashing down the mountain. That's kinetic energy. Kinetic. The boulder sitting high upon the mountain. That's potential energy. Potential. Energy in motion is kinetic. Energy that's waiting is potential. But whether it's kinetic or potential, both of them are energy. Olé! You stretch your rubber band and then release it. That's kinetic energy. Kinetic. You stretch your rubber band and then you hold it. That's potential energy. Potential. Energy in motion is kinetic. Energy that's waiting is potential. But whether it's kinetic or potential, both of them are energy. Olé! The heat that comes when gasoline is burning, that's kinetic energy. Kinetic. The energy that gasoline was stored up, that's potential energy. Potential. Energy in motion is kinetic. Energy that's waiting is potential. But whether it's kinetic or potential, both of them are energy. Olé!
All right, guys, so kind of a silly little video, but I think that really helps to demonstrate the difference there. Kinetic energy is anything that's moving or it's releasing energy. Potential energy is anything that's stored up energy or it's not moving. And this all comes back to that law of conservation of energy as we're transferring back and forth. Energy cannot be created or destroyed. It can only change form. And the total amount of energy in the universe never changes. Now, if you guys look at the beginning of this, when we zoom out, the reason why I chose to do this with a tree is a lot of people think that that tree is growing from nothing, and that doesn't go along with the law of conservation of mass or matter of energy. It really does. You can see there's apples on the tree. That's going to give you energy. That's got stored energy, which would be a form of potential energy, and you eat the apple, and when you eat the apple, that releases the energy. Then it goes in your body and you can use it. You might say, well, the apple came from nowhere, but it didn't. It came from a seed, and the way that it grew was it used sunlight, it used oxygen, it used water. So it combined all those things and took that energy from the universe that was in the form of oxygen and water and sunlight and converted it into potential energy for the apple. So you can see the amount of energy never really changes, it just changes form. All right, guys, I hope you guys all have a wonderful night. Make sure to do your quiz on the back. Write some good questions. There's lots of good thoughts here. You definitely have some questions about roller coasters. Those are always fun to think about. So you guys have a great night. I will see you tomorrow.